Okay, to wrap up our week here, I want to show you how to solve a system of inequalities. So the whole week we've been looking at systems of equations. Systems of inequalities are very similar, and we solve them by graphing, which is kind of a nice break from all that algebra, the linear combination and the substitution and the word problems. So this is kind of a nice breather to end the week with. I don't think you're going to have any trouble understanding this. And I just want to go over one for you in this video here in case you need something to refer back to. It says here, solve the system of inequalities by graphing. So remember, inequalities are distinguished by the inequality signs. They're in slope-intercept form, so they're just like lines that can be graphed in slope-intercept form. And then we also have to shade because they have many more solutions than an equation would. Okay, so to start here, y is greater than negative 2x plus 1. So slope of negative 2, y-intercept of positive 1. We're going to graph that in the coordinate plane. We'll mark our y-intercept, and then it goes down to right 1, down to right 1, do a bunch of those. Go the other way, up to left 1. And remember, when we draw this line, this one is going to be a dotted line because y is only greater. So the points, the ordered pairs that actually fall on the line are not solutions. So we symbolize that by keeping the line dotted. And now we have to shade. Now remember, there's two ways to do this. You can test the origin. The origin doesn't fall on the line, so I could plug in a 0 for x, a 0 for y, and see whether or not it comes out to be a true statement. If it does, shade on that side. If it doesn't, shade the other. Or you could use the shortcut. Remember the little gravity shortcut here. If you imagine this is like a mountain face and you're climbing up the mountain. Well, since y is greater than negative 2x plus 1, all the ordered pairs are going to be above. They're going to be on the mountain, right? So that means you're going to be shading on this side. This will be where all the greater values are. So that's our solution. A dotted line with a slope of negative 2 that passes through positive 1, and we shade above the line. Okay, so for the next one, y is less than or equal to x plus 3, already in slope-intercept form. This time the y-intercept is positive 3, and it has a slope of positive 1. So we'll just do a bunch of points like this. A few more going the opposite direction. And this line we're going to leave solid. Because remember, the ordered pairs that fall on this line this time are solutions. These do work. So we're fine with these. We're going to leave it just, I've got to move this a little bit. We're fine with these solutions. They are included, unlike the first inequality. And this time y is less. So remember, we shade beneath the line this time. So if this were a mountain, you were walking up the face of it, above the line would be on this side. But since y is less than or equal to x plus 3, we shade below the line. And it looks like this. Now this graph is getting a little bit messy. And the only thing you have to interpret here is where the solution is. And the solution to a system of inequalities is simply the double shaded region. So it's this region over here to the right. It only includes this double shaded region, including the points that fall on this line. That would be the solution to this system of inequalities. These ordered pairs that lie in the purple region are solutions to the first one, but not the second. The ordered pairs that fall in just the blue region are solutions to the bottom inequality, but not the first inequality. So it's the double shaded region. Anytime you're looking for a solution, just look for where the shaded regions overlap. And that's all there is to it.